All right, let's continue with the exam review and let's look at how to sketch a polynomial function. So I'll start with intercepts. For an x-intercept, I'm going to let y equal 0. That means you take the original function, you replace the f of x with a 0. We'll do a little factoring on the right-hand side. What could I take out of these two terms? X squared. It would leave x plus 1. Is that right? Take each factor, the x squared, set it equal to 0, and the x plus 1, set that equal to 0, and you end up with x equals 0 and x equals negative 1. So there are two x-intercepts. One at 0, 0, and one at negative 1, 0. Everyone okay with that? Next thing we'll do is the y-intercept. For the y-intercept, we let x equal 0. So that means I'm going to find f at 0. I'm going to replace the x's with zeros. And you'll see that f at 0 is just going to equal 0 cubed 0 plus 0 squared 0. F at 0 equals 0. And it's just the same as this point right here. X and y intercepts. Now when it comes to asymptotes, there are none, okay, for your polynomial functions. There is no vertical asymptotes because it has a denominator of 1, and 1 can't equal 0. So let's move right on to the intervals of increase and decrease. So we'll take our function, f of x equals x cubed plus x squared. How do you find the intervals of increase and decrease? Find the derivative. Good, Hinchy. What's the derivative of x cubed? And what's the derivative of x squared? Nice. I'm going to factor that. What could I take out of these? An x. It would leave 3x plus 2. I want to get my critical values, the values of x that make the derivative equal 0 or make it undefined. Well, nothing's going to make it undefined, but what would make it equal 0? If I take the x and set it equal to 0, and I take the 3x plus 2 and set it equal to 0, well, there's one critical value or critical number. And there's the other, negative 2/3. I subtracted 2 from both sides and then divided by 3. So I have two critical values, x equals negative 2/3 and 0. I'm going to make a number line. That goes from negative infinity to positive infinity. On that number line, I'm going to mark my two critical numbers, negative 2/3 and 0. How many intervals did I create here on this number line? 3. The first one goes from negative infinity to negative 2/3. Now, if I want to do the first derivative test, if I want to figure out if my derivative is positive or negative, because remember, a positive derivative, or if your derivative is positive, means that your tangent lines would all be positive and your function would be what? Increasing or decreasing? Increasing. Okay? If your tangent lines are negative, if they have a negative slope, it would mean your function's decreasing. Cool? So let's pick a number between negative infinity and negative 2/3. Any number at all. Negative 1. Wicked. And I'm plugging that in for x right here. it would be a negative, right? That first factor would be a negative 1. What would the second factor be? 3 times negative 1. Negative 3 plus 2. It'd be a negative as well, right? What's a negative times a negative? Positive, good. Something between negative 2/3 and 0. Negative 1/3. Awesome. So if I fill a negative 1/3 in for x, remember I'm testing the first derivative, this first factor would become negative 1/3. Think about this. What's 3 times negative 1/3? Negative 1 plus 2. What's a negative times a positive? A negative. And then give me something between 0 and infinity. A 1. This would be a positive 1. This would be 3 times 1, 3 plus 2, positive 5. What's a positive times a positive? So here's what I know is happening. My curve looks like it's increasing, and then it's decreasing, and then it's increasing. Does that make sense? Let's state that. State the intervals of increase and decrease. It's increasing on negative infinity to negative 2/3 and 0 to infinity. I picked the intervals with the plus signs on them, or above them. Where is it decreasing? Negative 2/3 to 0. Wicked. What do I have going on right here? It's going from positive to negative at that critical number. Increasing to decreasing. I got to hit a what? A high point, a maximum. Wicked. And the opposite situation here. It's going from decreasing to increasing. So we have a local min. Which brings me to my next bullet. How do I find my local maximum value and my local minimum value? Well, where does it occur? My local max occurs when what equals negative 2/3? X equals negative 2/3. And if I want the height of the function when x equals negative 2/3, I would go back to the original equation and just fill a negative 2/3 in there. So let's do that. So I have a local max when x equals negative 2/3. And I have a local min when x equals what? 0. Good. Here is my original equation. X cubed plus x squared. I am going to replace the x's with a negative 2/3. And I end up with f at negative 2/3 equal to, what's negative 2 to the power of 3? Negative 8. What's 3 to the power of 3? 27. Good. Plus negative 2 squared. 4. 3 squared. 9. How do I add those? And what would the lowest common denominator be in this case? 27. 4/9 would become how much over 27? 12 over 27. And what do I get for an answer? F at negative 2/3. 4 over 27. Is that okay? This one's an easy calculation. The minimum occurs when x is 0. We already did it when we did our y-intercept. So you wouldn't really have to show this calculation again, but what does it equal? Okay, so I have a minimum at 0, 0. I also have an x and y intercept there. I have a maximum at negative 2/3, 4/27. Cool. What comes next after the intervals of increase and decrease and the maximums and minimums? Yeah, my intervals of concavity. How do we do the intervals of concavity? I got to find the second derivative. So the first derivative was 3x squared plus 2x. I'll leave it here. What would the second derivative be? 6x plus 2. Wicked. Everyone okay with that? Now, if I wanted to factor that, I could take out a 2. It would leave 3x plus 1. Yes? When I go to get my critical values. Does this make sense? Does 2 equal 0? No. Okay? So there's really only one critical value. 3x is going to equal negative 1. What would x equal? Negative 1/3. I'm going to do a number line again. From negative infinity to positive infinity. Place your critical value, negative 1/3, on there. Two intervals from negative infinity to a negative 1/3 and from negative 1/3 to infinity. You have a nice number here that I could use. Negative 1 on the left. I'm plugging it in here. I want to see if the second derivative is positive or negative. If the second derivative is positive, what does that say about my curve? It's concave up. That's right. The curve would be above all the tangent lines, or all my tangent lines would be below the curve. If it's concave down, okay, that means my curve is under the tangent lines. What's 3 times negative 1? Negative 3 plus 1 times 2. Negative 4. Okay? What would I fill in here? 0. Okay? 3 times 0 is 0, plus 1 is 1, times 2 is 2. I could have also filled it here. 6 times negative 1 is negative 6, plus 2, negative 4. 6 times 0 is 0, plus 2, positive 2. What am I going to say? Concave down, okay? We're starting with concave down. On to negative 1/3, negative infinity to negative 1/3, and concave up on negative 1/3 to infinity. Is that okay with everyone? Doesn't matter if my second derivative test goes from negative to positive or positive to negative. As long as the sign changes at your critical value, what are you dealing with? What's happening when x is negative 1/3? It's not a max, it's not a min. What do you call it? An inflection point. It's a little twist in the curve. Okay? How do I figure out where my inflection point is? That's right. Okay? I'm going to go back to my f of x equals x cubed plus x squared. And I'm going to replace all of the x's with a negative 1/3. Remember, anytime you want a height or the function's height, the y value, you just plug x into the original equation. That original equation, this here, that's a formula for finding heights, for finding y values. What do we get? What's negative 1 cubed? 3 cubed, we already did it above, 27. Negative 1 squared. 3 squared, we already did it above, 9. How do I add these? Common denominator. Okay? So we end up with negative 1 over 27. 1/9 would be how many over 27? 3 over 27. Add the tops. Leave the bottom alone. 2 over 27. When it comes to putting it all together, all right, let's get a picture out here. Find a graph. Everyone okay with this? I'll count by thirds along the x-axis. Because if I look at my x values, I need negative 1/3. I need negative 2/3, 0, negative 1, so on. Okay? So I will go like this. 1/3, 2/3, 3/3, 4/3, 5/3, 6/3, 7/3, 8/3, 9/3. 9 over 3 would be 3. Does that make sense? Negative 1/3, negative 2/3, negative 3/3. Negative 4/3, negative 5/3, negative 6/3, or negative 2. 7, 8, 9, negative 3. Is that cool? This would be 0. Now look at your y values. I've got 2 27ths. I've got 4 27ths. I need a height of 0. That's it. So if you wanted to, you could go 1, 2, 3, 4, 5, 6. Let's do this. 6 over 27. Which would reduce. You okay with me counting by 27ths? So that's 2 over 27. That's 3 over 27, or 1/9. This would be 4 over 27. And I do the same thing down here. Negative 2 over 27, and this would be negative 4 over 27. So each block is a 27th. When it comes to making the sketch, plot all our points. So let's start there. Where were my x-intercepts? At 0, 0, and negative 1, 0. With me? And my y-intercept was also 0, 0. So I'm starting there. 0, 0, and negative 1, 0. Any issue? The next points I found were my maximum at negative 2/3, 4 27ths, and my minimum at 0, 0. So to get to negative 2, let's plot this blue point. That means I'm going to go 1 2/3 to the left and up 4/27. Oh, 4/27 for the maximum, right?
Oh, yeah.
The minimum was 0, 0. What other point did I have? A maximum and a minimum. And this guy right here, what was this? Right. I'm going to go 1/3 of a block to the left and I'll go up 2/27. Do I have any other points? No, I've got my x-intercept, my y-intercept, my maximum, my minimum, and my inflection point. So from here, it's a matter of drawing. Keep in mind, it increases, decreases, increases. So it's going to have this general shape to it. And we also know that it's concave down. My curve would be below the tangent lines, and then concave up. So here's what this would look like. It's going to spin around. And then right here, there's like a little twist. That's the point. This purple dot is the point where it would go from being concave down, all my tangent lines would be above the curve, to concave up. Okay, all my tangent lines would be below the curve, or my curves above them. And I'll spin it back this way. Arrows on both ends. That's what that curve would look like. It is a cubic function. Your exam will have a polynomial function on it. Cool? That's that.